So, hello everybody, hello Americas. My name is Jörg Rommelfanger, and I'm very grateful to have the opportunity to present to you today the latest innovation that we have made for the paint shop. I'm based in Germany. I'm running the automotive business line in Germany, where we are also hosting a paint lab with the latest technology, especially what I will talk about today, the Pixel Paint solution. So, I'm almost 10 years now with ABB in several management positions, but actually my whole life in robotics, almost 20 years with a robotics background. So then I will step into the presentation. I will talk today about the latest technology that we have development for the paint shop. And when I talk about paint shop, I'm talking about the area of the top coat lines, where we have the robots and the application equipment in. Especially on this area, we are facing a couple of challenges right now that we have to deal with. Of course, the biggest challenge that we see is the reduction of emission and energy consumption, because many of our customers have actually announced a very aggressive target when it comes to CO2 emission and also on the VOC emission. So that is basically the biggest challenge and the biggest driver right now for new technology. What does that mean? That means we have to work significantly on the reduction of the overspray, because the overspray is actually causing a lot of those emissions. And I guess, as some of you might know, 70% of the utility consumption in an automotive factory are currently coming from the paint shop. So there's a huge challenge, but also a huge potential in it. If we can reduce, of course, the reduction of the overspray, that would help us result in an enormous savings in energy costs. And on top of that, especially what we see in the two-tone trend on the cars, that is the masking and demasking process. That is also causing a lot of waste coming from the auxiliary material of masking those cars. But I will come to this a little later. Another trend that we see is flexibility. I guess you have heard quite a lot in the presentations before that one of the key drivers for automotive factory in the future is flexibility and scalability. Also coming from the uncertainties that we see in the volumes in the transition from the combustion engine cars to the electrical vehicles. We are working since quite some time on a cell-based concept. That means bringing our top coat cells and the base coat and the clear coat, primer, etc. Then we are bringing it into modularized, standardized solutions to make integration easier and also scalable. And with the latest acquisition that you have also seen in the discussions before from the company ASTI, one of the key drivers of autonomous robotics, we are also looking now into bringing AGVs to the paint shop, mainly, of course, in the transporting the skids from A to B, and also maybe in the sealing area. That is also huge potential that we are seeing. Last but not least, increasing productivity. It's also, I would say, a mega trend in the paint shop. Full monitoring down to the application level. So we have actually, as ABB, have been an early mover in collecting data. We have installed process data analytics systems already 10 to 15 years ago. That has helped us to increase productivity, but also help us to develop new products, especially in the area of atomizers and things like that. Improved diagnostic for predictive maintenance. That is also a key topic that comes with the process data analytics ecosystem, and by that also focusing really on the transfer, reducing the transfer and efficiency. This digital layer basically should help us by collecting the data and monitoring the spray patterns and process data, that we are aiming for like a closed loop approach, that we are really bringing the results that have all the process parameters that have an influence finally on the quality, that we can control it in a closed loop communication. We are not there yet, but we are gathering the data. We have installed additional sensors into our products. Some of you might know that we have released the first connected atomizer some time ago, where we have brought for the first time additional sensors into the atomizer, gyroscopic sensors, vibration sensors, RFID sensors, so that we can really monitor the data very close to the application, very close to the process. So a lot of demands and a lot of challenges that we see coming from the production area. But what we can also see at the same time are new trends that are coming from the design. And some of the trends are actually not new, as you can see on the pictures. The two-tone application, for example, we have seen it since quite a while. We have seen it already in the 50s and the 60s, where we have cars with two-tone colors. But what we have recognized the last years is that really the two-tone is entering the mass production in the automotive industry, especially when it comes to the black roof area. This is, I would say, has become really a standard in the production. On top of that, what we can see is huge demand coming from the individualization of the products. So putting your own design on a car, having logos, graphics, whatever that means, everything in the paint, that is something what we can see recently, and that gives, of course, the designers and the salespeople in the automotive area creates, of course, a lot of creativity, which is not always appreciated by the production guys. But this is what we can see. And if we look especially into the two-tone area, how it is actually installed in the mass production, it is quite a complex and a quite, I would say, inefficient process that was installed. So what are the automotive manufacturers currently doing? In very simple words, they are running the car 2 times through the paint shop. And that is, of course, not efficient at all, because you are, on the one hand, losing the productivity. And on top of that, you have this very complex masking and demasking process, manual processes, people that are putting the tapes on the car body and then sending the car back into the paint shop to go for a second round. And with our latest technology, the overspray free pixel paint solution, we can definitely change that, because then you can basically add the pixel paint cell and the technology at the end of the traditional paint line. Or you even go out as a bypass, take the car body out of the production line, applying the deco or the second tone, and then bringing it back into the original production line. And that makes, of course, the process much more efficient in terms of cost, but also in terms of waste and sustainability. And we have collected some data, as you can see on the right side, that underlines a little bit the savings that we see. So masking, demasking currently is a very labor-intensive process. We have almost seen 20 people in a paint shop working just on the masking and demasking process. On top of that, you have with the traditional paint process, you have another paint loss due to the transfer efficiency. And the biggest portion, as I said earlier, is all the auxiliary material that is not just waste and not environmental friendly, but it's also a huge amount of cost that we see there with all the demasking and masking processes. So if you can take all that out, you would significantly increase the productivity and the efficiency in the top coat line when it comes to two-tone application. Good. Just to underline it with a couple of numbers, as I said, labor cost is very significant. We have seen paint shops with almost 20 people. I mean, just assuming that you have 16 people, 45K each and 3 shift operations, you can easily save $2 million per year if you are just taking that out. On top of that, as I said, even higher is the auxiliary material that you need for the masking and demasking process. That could easily end up in $5 to $6 million per year. And then, of course, the paint loss caused by the overspray that we see in the additional round is at least also $500,000. So huge potential that we can actually save when we can get rid of all of those costs and processes. And on top of that, what we should not forget is all the, let's say, inefficiency in the paint transfer is of course causing a lot of indirect costs when it comes to additional ventilation, when it comes to KPR, and that would all be eliminated if we can go to 100% overspray-free paint application. So that brings us to our solution. So that is actually the Pixel Paint solution as we have it today. Summarizing maybe quickly the customer value. Productivity, as I said, eliminate the double cycle time currently required for all the two-tone applications that we see on the market. Flexibility, significantly deduct CapEx and OpEx for the masking and demasking process, mainly coming from labor cost, auxiliary material, and of course the inefficiency of the paint process itself. And then finally, the quality. Zero overspray in the paint is of course environmental friendly, and that is the overall top target that we have seen everywhere, is the reduction of the emissions, unfriendly environmental emissions coming from the CO2, from the high energy consumption, but also from the VOCs. And then simplicity. Remove the need for manual and time-consuming masking, demasking process. So I think this is a very good value proposition that we can give with the Pixel Paint when it comes to two-tone application, but also to the decor and individualization processes. So what is Pixel Paint about? Pixel Paint is what we call a functional module or a function package. What does that mean? That means the whole technology, the process equipment, is fully integrated into our robot ecosystem, to our robot platform. That means what you can receive and what we have as a functional module is a fully dressed robot, a paint robot, high precision paint robot, IAB 5500, for example, with this printing head attached. And the printing head is a high DPI inkjet head, which has almost 1,000 nozzles, which we can individually and independently control. And that allows us to create very sharp edges and also very smooth overlapping. I will come to this a little later. But this is not all, because the past generation for the Pixel Paint is of course much more complex, as you probably know it from the traditional paint shop with the atomizer, because you have to be very accurate in your path planning. And that's what we have brought into our Robot Studio tool. I think this is a well-known tool when it comes to robot simulation and path generation. And we have embedded it into our Paint Power Pack so that it's easy to use, easy to program, and teaching free finally. So you can import CAD data, and then based on the geometry, you can automatically generate the paths. And the tool also calculates how to control the Pixel Paint head at the same time. For those of you who are familiar with the RBB paint equipment, we are using the same process control. So we are also programming in brushes and things like that. And everything is fully embedded into our robot process arm as well. So really a fully functional module, easy and ready for integration, combined with a powerful software platform that comes with it. Going a little bit more into the detail, into the printing head itself, it is the rear holder that we actually attach then to the robot flange, to the hollow wrist from the paint robot. Then we have the metal body, which is EX certificate. So the whole system is, as you know it from the paint robot, is purged, so that it is also certified for explosion areas. And then for the front head, you can see, if you look into this view A, you can actually see the printing head, the different nozzles, and the plate where we are applying the paint. So, and this, as I said earlier, this consists of 1,000 individual controlled nozzles that we can control via piezo element in the inkjet head. And that allows us to really apply very, very sharp edges and any kind of graphic that you know from a traditional printer. Then if it comes to the paint is actually circulating all the time through the printing head. So that means we have a continuous flow of the paint material, and then with a trigger valve for each each individual nozzle that is actually pushing out then the paint, the drop of the paint, depending on the, of course, on the graphic, on the movement and everything. So that means, in simple words, we can control, of course, the flow, so the number of drops that we are pushing out, but we can at the same time also control the size of the drop that we are pushing out. And that the combination of both brings us to a very, very nice surface and a very, very clean paint appearance later on the car. So that means this process is applicable for more than 1,000 nozzles. And the pattern that we are actually applying is roughly 100 millimeter on the pixel paint head. Good. Then another big advantage of this individually controlled nozzles is if you're painting, for example, a hood or roof or whatever. I think the tricky part is always to bring the different parts together. That if you don't have the flexibility to control the nozzles, you have to be very, very accurate, that you really bring each part to the next one. So that is a very complex process that we are actually solving by also controlling the different nozzles. What does that mean? That we can, in the overlapping area, we can actually reduce the thickness in the overlapping area by just switching off a couple of nozzles. And that gives really a very, very clean and fluent overlapping area, as you probably know it from traditional paint processes. And that is really, really nice, because then you have basically the same appearance as you know it from applications like atomizers. So coming a little bit to the graphics. As I said, we are not just working on two-tone application. The beauty of this inkjet principle is that we can apply any kind of graphics to a car body or to other components as well. And how does it look like? So you are taking just a traditional picture, BMP or TIFF files. You can import them into our software tool. You can generate the passes with Robot Studio. The software automatically converts it to the digital data, binary data, that we are then sending into the controls of the pixel paint head. And we are synchronizing it with Robot Studio with the motion of our robot. So that means any kind of graphics, any kind of application you want to bring to the car body, you can do it with pixel paint. And as I said earlier, this is not always what production guys like. Flexibility in decor and design, but it definitely it increases the creativity, of course, in the sales and in the design teams, because then you finally you could even think about fully individualize the car that you are getting. We have done things like putting fingerprint, for example, on a hood and things like that. So really room for creativity, I must say. So then, unfortunately, this was a video on the top left, which is not running, but I will show you some videos later on. So summarizing a little bit, the Pixel Paint solution, it is a solution, a technology for contrast, also two-tone painting, but also for logo and any kind of graphics that we can apply. The beauty with it is non-overspray. That is, of course, has an effect on energy consumption, on CO2 emissions, things like that. And if you would think even further, so if you would, for example, paint a whole car body with such a technology, we are not there yet, but we are working on it. You could even think about a totally different design in the paint shop. For example, all the paint separation would disappear, which is a huge potential in savings of costs and also emissions. So examples, black roof coloring without masking. I think that is the most common use case as we see it today, but we see a tendency and a trend for fully individualization with logos, with graphics, with fingerprint, any kind of design that we can bring on the car body. So what does that mean? With this technology, even in a growing automotive market that we see till the year 2027, we think that we can reduce with Pixel Paint almost 35% in all the, let's say, key cost drivers and efficiency drivers in the top coat area of the paint shop. And that would mean, for example, 200 kilotons in paint consumption, another 60 roughly in the VOC emission, and another 6 tons of CO2 that we can reduce if we just reduce the efficiency or the transfer, if we just reduce 35% of that. And we have not even looked into the potential in other areas than automotive, because Pixel Paint, I think, is also super interesting technology. For example, in the wood and furniture industry, we could even look into bus and then electronics, 3C, consumer electronics, toys, aircrafts, and many, many more, where we can paint. And as I said in the slide before, the setup, the paint booth can really look differently, and that would really bring us into a greener painting world and to a greener future in the next coming years. So that actually brings me to the end of my presentation. I would actually like to show you some videos at the end. For example, one video where we have basically applied, oh, that is the wrong one, let's go for this. This video is actually taken from our lab in Germany, here in Friedberg, where we have a new paint booth, a new paint lab installed with a fully dressed IAB 5500, equipped with a Pixel Paint system, installed on a rail. And we are currently running tests with almost 30 different customers. So we see a huge pull from the market and a huge interest. But it all starts with validating the processes. So that's why we are investing quite a lot now into the lab. And I would like to show you a quick video where we are applying a black roof in a car. And here you can actually see that we can work into both directions. We have the spray pattern that is roughly 100 millimeter, and you will hardly find anything on the overlapping, because, as I said, we can individually control the nozzles, and by that control also the overlapping area. So extremely good appearance and extremely promising results that we see with the Pixel Paint. On top of that, we have also done tests with the same car body on the vertical surfaces, because this question is always coming. Can we also apply the paint on the vertical surfaces? Yes, we can. And the results were actually surprisingly good, we must say. We now have not even expected such good results. And we are definitely using the same paint material for the roof as we do it for the verticals. And we have not found any kind of sagging or paint flaw or something like this. So really an extremely good result, not just on the roof and on the hood, but also on the vertical areas like the doors. Another quick example where we're also applying now paint on the lines, on the A and C pillar. Quite complex geometries, but also possible pixel paint to apply paint in those areas. Okay, then maybe some last impressions, where we have done tests also on metal sheets with different kind of graphics. You can see any kind of graphic is applicable, so you can really individualize the design of the car, and there's an enormous room for creativity and individualization. And then one last slide. We are even able, and that the picture on the left side is not just a bad quality, as some of you might think. It is really requested from a customer that we have such a structure on an uneven surface. And even this is possible with pixel paint and with the individual controlled nozzles, that we have like a haptic, like an uneven surfaces on the car body as well. So really impressive what we have seen there. And of course, also in the plastics area, there's a huge potential. We have applied already material on spoilers, on wings, on plastic parts. And as you can see on the right side, we can even cover the edges. If we turn around a little bit the pixel paint head, we are not just applying on flat surfaces. We can even work on the edges and have a very good paint coverage also on those areas. Okay, that's actually brings me to the end of my presentation. I would leave now I would like to start the Q&A session right now, and I would really appreciate if you would give some feedback by scanning the QR code and provide feedback on the presentation and on the things that you have actually seen. So, and then I would like to open for Q&As. I have seen already a couple of questions coming. First one coming from Rick. Does the paint material require a clear coat? Yes, if you want to. So what we are applying is a solid black paint in those use cases, but we can also apply, of course, any other color if you want. But of course, the final process is a little bit the same. Then we will also cover this with a clear coat. The clear coat is actually, we have currently it's done in a traditional way, so with atomizers or something like this. But we have also started looking into applying clear coat via pixel paint as the next step. I hope that answers your question. So, are these robots pre-certified for use in hazard locations in North America? Oh no, it's not going to check it now. Wait a second, please. Sorry. Hazardous locations in North America. I'm not sure if I fully get these questions. As I said, we are fulfilling with the robots. And with the pixel paint head, we are fulfilling all the requirements. We have all the certifications when it comes to the US, but also to the explosion areas. So this is actually what we are used to do so. As if you integrate it, then of course into an existing line, or create a new line, or create a new paint cell, then of course you have to do the certification for the whole cell. And that is either coming from us or from another integrator that is installing or integrating our paint solution. I think what we are always there to support, of course. So we are currently in many discussions with car makers, but also with tier ones, how to integrate it. And there are many possibilities. We have, of course, some space limitations when it comes to brownfield. So we really have to think about bringing it into the existing line. In addition, if the space is there, or that we pull out the car and create like a bypass, sending it through the pixel paint and then back into the existing line. But this heavily depends, of course, on the local, let's say, on the local requirements and the limitations that we are seeing. But there we are open to support. We are also dealing with integration, of course. We are not just selling the product, we are also responsible or feel responsible for the process. So we can always help you to take that discussion as well. So then maybe I can give some more feedback based on the questions that I have received in earlier sessions. We are currently dealing, for example, with 1K paint, so one component. Currently we are not able to apply 2K materials, and we are also neither able to apply metallic paint due to the particles and the ingredients that we have in there that would block our nozzles. So solid paint, any kind of colors, 1K, solvent or waterborne, that is actually what we can apply. Are there any further questions? There's another one from Roderick. The target distance, yeah, that's a good question. So it depends, of course, on the accuracy that you want in the graphics. Usually we are talking about 10 millimeters, something like this, 5 to 10 millimeters. If we are applying the graphics and you want to have sharp edges in the graphics as well, of course, you get a little bit closer. Then we talk about maybe 5 millimeters. But for the two-tone paint, I think we can say it's roughly 10 millimeters, and we are currently applying with a speed that is actually the target of 200 millimeters per second, roughly. So and that would bring us into a position that we could, for example, in a traditional paint shop with, for example, 60 jobs per hour, we would need 2 robots to go for a two-tone roof, for example. And then when do you anticipate adoption in mass production? Oh, I think pretty soon, I must say, because we are currently in the validation processes with almost 30 customers, not just OEMs, but also tiers. And there's a huge pull on the market. The idea is actually that we go into the first installation maybe within Q1 next year. So technology is there, functional package is ready, but it always starts with validation of the processes before you go into the mass production. That's what we are currently driving heavily in our labs with customers, so that we really bring the appearance to the level that is expected. And then for Q1, we are targeting for the first installation in mass production. So, is a monocoat material pigmented clear coat being developed for brownfield shop with a separate boost for two-tone application? I actually don't know. I'm not sure. I think we had some discussions, but I'm actually not sure. Rick, I have to come back on that question. I have to talk to our lab guys and who are actually working with the material suppliers very closely. We are currently in discussion with all the well-known suppliers, BASF, PPG, Axalta. They are all part of that discussion and part of that development. Then is unique paint materials needed? Yeah, a little bit. So I would not say unique, but what we are doing is actually we are modifying the regular paint a little bit. We make some adjustments in the formula, for example, in the viscosity to get it to the pixel paint. But that's actually all. So I would not say it's very unique paint material. It's some adjustments in the regular paint material. And as I said, compared to our competitors, we can use the same formula right now for the horizontal, but also for the verticals. So there's actually no adaptations. We have not seen any sagging or something like this. So that looks really, really promising what we have seen. So this unique paint, I answered this one. What about color change? Yeah, good question. We don't have a color change system yet. We can change the color, of course, but then you have to clean it and you have to bring solvent through the system. We have no fully automated color change yet. We are working on it. But what we have tested so far is that we have used, for example, 2 pixel paint heads with different colors working on the same graphics. So we have some very impressive graphics where both robots are working together with blue and black color, and they're working on the same graphic, and that looks really impressive. So no fully automated color change yet, but it will come, and we are working on that. The next step that we are bringing in is automatic cleaning device. That is also already developed but needs to be tested a little bit in our lab as well to find out how many cycles we can run without cleaning the pixel paint head. But those are all the things that we are currently investigating in our lab to get also clear answers for the manufacturers finally. Good. Any further questions? Yeah, long term. Yes, that's actually the vision. We are not there yet, but it looks actually promising for the outside. For the inside, I would put a question mark because those geometries are so complex that will definitely take some time and maybe also requires a slightly different technology. But for the outside, it really looks promising, even with, as I said, even the complex geometries like the fenders and wings and something like this. We have actually we have good results. Interior, I would say, big question mark on that. Maybe it's a combination. The next step is a combination between both technologies. Three-D vision on the end arm tooling? No, we have 3D vision, but not on the end arm tooling. We have it in the booth. So we have a 3D vision that basically gives us the position of the car, which is super important when you are getting closer to the edges, and it also gives us the position of the edges. So not on the robot, on the arm tooling. Maybe that is something for the future. I would really love to see so that we have it also as part of the functional module with the robot. Currently, we are working with traditional vision systems that we have inside our booth, as you know it from traditional paint shops. But maybe that's the next step, that we bring it to the end arm. So we have still some time for some more questions. Good. If no further questions, then I would like to end it here. Thank you very much for your participation. And whenever there are further questions, you can always reach out to the ABB team or to myself. And I'm really looking forward to working with you with this new technology, disruptive technology, and which really will help us to make the change in the paint shop in the future. So thank you very much. Have a good day in the Americas. Take care and see you soon. Bye-bye.